In this section, we're going to introduce the idea of encapsulation. Encapsulation is really something we've been talking about all along. It's the general idea that an object or a class should be self-contained, or the book uses the term self-governing. The key point is that classes don't provide more functionality to your program at large than your program actually needs. And what I mean by that is it's not going to give the outside program too much control over the parts that make up that object. Let's take a look at the diagram here. On my left, I have a little rectangle labeled as client. So this is really meant to represent your program. Then on the right side, I have another rounded rectangle that's labeled as object. So this is perhaps a class that we've created, and we've made an instance of that class, right? We made an object from it. The idea of encapsulation is that your objects are going to just make this interface available. So this interface, the way that I represent this as kind of lines come out of this is UML notation. But what this is indicating is you have, say, one method, two method, three method, four method. These four different methods are available, right? Those are things that are provided by this object that the client, right, the rest of your program, can actually use. Your actual object or your actual class may have other things inside of it. For example, it may have variables, right? It may have some data. It may even have other methods, right? It may not just be the four. But that other stuff that the object has, that's not going to be available outside of this object. The idea being that those methods or those instance variables are kind of just internal, right? They're something that lets the object implement its functionality, but they're not something that another part of your program should be able to tinker with. They're something the class should keep to itself. For example, we don't want to have the client accessing data inside of the object. The reason we don't want to allow this is because the client may change data in ways that are illegal. So think back for a minute to the die example from the last section. So in the die example, we had a member variable, and it was just called face value. And that particular variable was some random number up to some maximum number that the dice could roll. And we could imagine that if we had a client that was allowed to go in and change a bit of data, it could set that face value to be something that's higher than the maximum legal value for the dice that was being simulated, right? So we had a 6-sided dice initially. Well, if somebody else can reach in from the outside and change something, they can set it to be whatever they want, right? So they can set it to be something like 10, even though 10 is greater than the face value. And that's not something we want, right? We don't want our client to be tinkering with the data inside of our objects or inside of our classes because they might break something. Instead, we want to have our objects be encapsulated where they don't expose all these kind of unnecessary things, and instead they just have a interface, or I would probably prefer to call this an API. Interface is actually a specific keyword in Java. So let's just say this is an API. And this API, that is how the rest of your program uses this class or this object, right? It doesn't have to worry about all the things inside, right? That are maybe the internal support methods. All it worries about is that application programming interface that is kind of a list of the functionality that your class provides for the outside to use. So based on what we just talked about, you may be wondering what is the actual process for making our classes be well encapsulated, meaning making sure that the outside program can't tinker with things that it's not supposed to. Well, the way we do that is with the keywords public and private, and we've already seen these a few times. These two keywords indicate to Java who should be allowed to call a particular method or access a particular variable. For example, right, we had over in the die class, we had our face value. So our face value variable is defined like this: private int face value. Well, what that private modifier means is that face value should be private to that class. Meaning that nobody outside that class can actually access the information stored in that variable. They simply can't write code that involves face value. You can't create a new object and then go object.faceValue. That doesn't work. Only the methods inside the die object will actually be able to view that variable and what's inside of it. On the flip side, we have public. So when we make something public, for example, let's say we had a set value or set face value, then that says that that method or variable should be available not only to the stuff inside that class, but to anybody outside, right? To somebody else who created an object from that class, they're going to be allowed to call set value, right? It's public, so anybody can get at it. In the book, they have this nice kind of chart here, which summarizes variables and methods versus the public and private. So over here, right, for variables. Well, variables in general, we do not make public, right? Think of the idea of us accidentally setting the wrong face value, right, on a die. We don't want to allow that. So in general, right, we don't make variables public because that violates the ideas of encapsulation, right, making it self-contained. Then we have private, right? So if we have a variable that's private, that means that people can't change it from the outside. So in that case, we get what we want, right? We enforce encapsulation. Going down to methods, we can think of making methods public. When we make a method public, that means that anybody can access it from a particular class. The way you might want to think about this is that those methods are a service being provided to the rest of your program, right? The clients who use it. Because that method, right, anybody can call it. So anybody can use it to get work done. Then we come to private methods. For private methods, remember that only the other methods in the class, right, the things inside that class, will be able to call them or use them. So in this case, when we have private methods, what that is actually representing is support methods, right? Methods that will be used by other methods in a class to get their work done. Often they represent that you've decomposed or broken down a problem, right? Maybe you have a method that does a lot of stuff. For example, it downloads, verifies, and then displays a file. Well, you might have 3 different methods to support that one method, right? One that does downloading, one that does verification, and one that does display. So those would be support methods, right? All those would be private, and then we'd have kind of one master method, right, that would be public, that relies on those 3 different private methods in order to do the whole task, right, which is going to be displaying URL to a user or something like that. Before we walk through some examples of using the visibility modifiers public and private in an actual program, let's introduce a little bit of terminology. Oftentimes we'll need to implement methods that make information from a variable available, right? Variables, we said, those should be private so that we can have our objects be a good encapsulation. While sometimes we still need to provide functionality for that other class to be able to read that information. So thinking back to die, here we have an example that's with respect to the face value variable that we had made private previously. So let's look down here at the second one because this is the simpler one. So here we have get face value. Well, this kind of notation here, right, the word get in front, is what is called an accessor. So this is the name, the general name that people use for a method that returns the value of a variable inside of a class or inside of an object. And here, this is pretty simple, right? It's just returning face value, but there could be even more complex computation, right? There could be other things happening over here. Again, the key is method that accesses variables inside of a class. We call those accessors, and we use get in front of the name to indicate what it generally does. So looking up here, we have set face value, right, which is kind of the opposite. So in this case, we call this a mutator. And a mutator is going to be a method that changes the value of one of the variables inside of your class, right? So in this case, we're setting face value. And you can notice here that this is where we have kind of a chance, right, to keep our data safe, right? This is where we had our if statement that validated value to make sure it was a valid face value before we stored it into the actual variable, right? So we didn't get anything bad, right? We didn't get the number 10 or 20 showing up on a 6-sided die. Remember that our goal is to have a well-encapsulated class. We want to make the class be self-contained, and we don't allow other parts of the program to tinker with it and break something. So here, our method essentially has made accessing, right, or changing that variable into a safe operation. Now that we've spent a decent amount of time talking about this stuff kind of just up on the screen, let's actually look at some code and see what this stuff looks like. So over here I have another example from the book. So this is the count flips class, or driver I should say, and then the coin class. The purpose of this program is to flip a ton of coins and then count how many of those are heads and how many of those are tails. So over here, let's start by looking at our driver, right, our main method. So over here I have count flips, and you may notice that count flips is simply a public class, right? So it's a class that's available for anybody to use. So let's look down to the main and see what's happening over here. So first of all, we create a variable called flips, and we initialize it to 1000. That's going to be the number of times we flip a coin. Then we have variables to store the number of heads that are rolled and the number of tails that are rolled. After that, we initialize our class, right? The coin class, right, which is over on my right, is a custom class that had to be implemented in order to make this program possible. Down here, we have kind of the heart of our program, which is the loop. The loop is going to run flips number of times, right? So this loop here is going to run 1000 times. The first step in this loop, right, for every iteration, is that we go to that object, right? We create an object from the coin class, and we call flip on it. So I know, right, that flip is part of kind of the publicly available interface or API, right, that the coin class provides to me. So that's something I'm allowed to use, right? Maybe there are other methods in that class that exist. Maybe I'm not allowed to use them, right? But for sure, this is public. This is part of the functionality it provides to everybody. After that, we jump down to the if statement. And the if statement calls another method. Again, this is a method that must be public instead of coin, otherwise we won't be able to call it. And this particular method here is meant to check whether the value on that coin, right, the side that's facing up, is heads or not. Based on what that returns, we're either going to increment the heads variable or the tails variable. So as a whole, just remember that this thing is going to execute 1,000 times, right? And every time we flip, check if it's heads, and then update the appropriate variable. Once our loop is exited out, we'll jump down to the print statements. And the print statements here, right, they're going to print out flips, which is 1,000, and then it'll print out however many heads we saw and however many tails we saw. To finish understanding this program, we need to look at the coin class as well. But before we do, let's think for a moment. From the perspective of count flips, the coin class is, first of all, a class that I can create without giving any parameters, right? It doesn't have anything that's required. So I can create it like that. And then it's a class that provides me a flip method and an is heads method. From the point of view of this class, that's the only thing that coin does, right? It provides those two methods. This class here has no idea how coin works, right? How it generates a random number or how it stores which face is up on the coin. For me, I think of this in terms of abstraction, right? Our class is meant to be an abstraction for a coin, right? That coin could be represented or could be implemented in many different ways, but from the point of somebody else, right, from the point of an object using that class, right, that coin class, all I care about is those little bits of functionality that are exposed to me, right, the flip and the is heads. Doesn't matter how those work. As far as I'm concerned, this thing is an abstraction, right? It provides me that stuff, and I don't have to worry about how it's implemented on the back. That said, let's go look at the coin class and see how that was put together. So over here we have coin, and coin again is a public class, right? So it has to be public, otherwise coin flips, right, won't be allowed to create instances of it, right? It wouldn't be allowed to create objects. So here our visibility modifier is making sure that somebody else, right, another class, can make instances or make objects from this class, from this coin class. Scrolling down, we see the rest of the code inside of this class. So the first thing up top we have is our member variables. Remember that we said it was convention to put our variables at the top, right? So that when I'm reading my class, I can see what's available without having to look for it, right? I can see all the information that class stores or all the state that it stores. And in this case, right, I have heads and I have face. And for both of these are both marked as private. Since they're private, that means that nobody outside, right, no other class, can come in here and either read it or write it. The reason we're doing this is so that we have a well-encapsulated class, right? We don't want to have somebody else tinkering around with these values with this class not knowing about it. These variables are pretty simple, so we might not have to worry about count flips actually breaking something here. But this is kind of our best practice, right? For much more complicated classes, you can imagine how much more important this is. Since our variables are set up properly, let's scroll down and take a look at the methods. So in this case, right, I have a constructor and then 3 other normal methods. The constructor is public, right? So that means that anybody's allowed to call new, right, to create an instance of this class. And then inside of our constructor, right, we have something set up to initialize this whole thing, right? So it gets initialized by calling flip, right? So that we have some side showing up. Looking down, we then have the flip method. The flip method here is declared as public. So again, this is going to be something that everybody can call, right? That was actually the method over here that I called in count flips, right? Every iteration of the loop, I had to call flip. Since this method is public, I can think of it in terms of providing a service, right, or functionality for the rest of my program to use. If it had been private, then it would have been more likely that it's some sort of support method that gives functionality that's needed for some other public method to actually run. The functionality in here is pretty straightforward. So we're basically going to get a random number, either 0 or 1, and then we're going to store that into face. Moving along, we have is heads. If heads is also public. Is heads, right, was the one being used over here in count flips, right, to check to see what the result was. So it's public as well. This time it's Boolean. And then inside we have this simple return statement here, right, that checks to see whether face is equal to heads. Remember that heads, right, heads we declared to be 0 because what we want to do is just record what is the integer that corresponds with a heads being shown. These two methods provide the bulk of the interface or the API that makes this class useful, right? Flip and is heads. We also have a third thing in here, which is toString. More than anything else, this method is for debugging, right? This is just something that prints out heads or tail based on what is the current kind of facing, right, in the face variable. It's just a way for us to see what's going on. So let's compile these two classes and run them and see what we get back out. So over here we can see we flipped 1,000 coins. From that we got 503 were heads, 497 were tails. I mentioned a few minutes ago that I like to think of classes in terms of abstraction, right? They give me some interface, right, or some API that defines some functionality, but I don't really care how it achieves that functionality, right, as long as it gives it to me. So let's see what that means really quick. So right now, this class, the way it's implemented, is using an integer to store the facing. And I don't know about you guys, but to me that's a little bit off. I'd like to make it a little bit simpler. I'd like to think about restructuring this thing in terms of booleans instead of an int. After all, I'm just flipping a coin. So here's what I'll do. First things first, I need to create a new variable. So I'm going to replace both heads and face right now. So I'm going to create a new boolean called face showing. I'm going to go ahead and comment out the other two variables. And then I have to go through the rest of my program and update it. Under this line, I'm going to start writing in my new code. So I'm going to put a random object here, and we're actually going to have to bring in the random package as well. And we'll need this to create new random booleans. And then over here, right, once we have a random object available to us, we can actually create a random boolean. So we'll go face showing equal random dot next boolean. Now we can get rid of our original line. So now flip is in terms of booleans instead of in terms of ints or doubles, as it may even be. Over here, right, for is heads, we need to update that as well. And so we'll change that to be return face showing, right? That's our new boolean variable. So we didn't even have to do this comparison anymore. We can just return the variable. Last thing up top, right, is that I need to add the appropriate package. So let's compile this. It looks like we forgot one thing. Let me go back over here, and this expression over here, I'm going to change it to is heads, which is actually better than what we have right now, right? We already have a method that's used to check if something is on heads, so let's actually use that over here on our toString. So let's try to compile again. Looks like everything's good. Let's try running it. And here we go. Flips 1,000, heads 519, tails 481. The thing that may or may not jump out at you here is that we made a bunch of changes over in coin in order to restructure it to use a boolean, but yet we didn't have to make any changes over in count flips, right? Because count flips doesn't actually know how coin works, we can restructure coin however we want, and count flips will simply continue to work, right? All count flips cares about is that flip and is heads work properly, right? As long as those two work the way they're supposed to, this method is going to work, right? There's not going to be any issue. Even though we've made whatever changes we want over in the actual implementation of coin, it doesn't have any impact on any of this stuff over here because we encapsulate everything, right? If I hadn't had these variables as private, right? If I had been allowed to update face or heads in this program, well, then you can imagine that I would have had to update my code over here wherever it relied on face and head. But since I made them private, that wasn't even an option, right? This class over here wasn't allowed to touch these at all. And that is an example of encapsulation, right? We've hidden away all the stuff that somebody else doesn't need to know about. That way they can't become dependent on it, right? That way this class over here, right, count flips, didn't become dependent on the two private variables. As a consequence of that, we were easily able to replace those variables, add in something new, and restructure our methods in a way that we thought was better, right? Instead of using an integer, we just used a boolean.